This is graphs of equations. So we're going to show how to plot a graph by its equation. So I'm going to use the example here. Y is equal to 2x plus 1, and what we're going to want to do here is plot this. Now I've got the Cartesian plane over here, and then I've got the table that we're going to use just to plot some points right here. Now this is going to be my x values, and this will be my y values. And I'm just going to pick a few here. So what happens when I plug 0 in? I get 2 times 0 plus 1, and we're just going to be left with 1. So I plugged 0 in for x, and we got 1 for y. So we're going to come over here, and let's say this is 1 right here, and we'll say that's 2, 3, and so forth, and we'll say that's 1, 2, 3, 4, 5, 6, and we'll label this as 7. I think we'll need that. Okay, so I plugged 0 in and I got 1 out. I think what I'm going to do here is change colors maybe so you can see this. So I plug 0 in, I get 1 out, so that's a point on the graph. Alright, let's just finish the table over here. So I plug 1 in, so 2 times 1 is 2, plus 1 is 3. So I plugged 1 in and I got 3 out. Okay, let's plug 2 in, so you get 4 plus 1 is 5. And then we'll plug 3 in, and that's going to be 2 times 3 is 6, plus 1 is 7. I think we'll just stop right there. So 1, 3. So 1, 3. I think I said I was going to change colors. Okay, and then 2, 5. So 2, 5 is somewhere about here. And 3, 7. So 3 and 7 is somewhere about up here. So these are just we got 4 points here in the plane, but of course there's infinitely many of them. Right, we've got a bunch of points in here too. If we were to continue like 1.1 and plug that in and so forth, and then you got points coming down in this direction. Right, so we get this nice smooth curve. This particular, it's a straight line. Alright, I'm trying to draw a straight line, runs through here with infinitely many points. Now we can write these as, for example, 0, 1 as an ordered pair, 1, 3, 2, 5. So these are points in the plane, and 3, 7. Alright, so our equation here represents all these points that are along this line right here. Let's look at some other examples. So I'm going to construct here the XY axis. about y is equal to x squared plus 1? So we plug some x values in. So let's plug 0 in, and what do we get? And I'm going to write these as ordered pairs here this time. Plug 0 in into here, and you get 1 out. Or I'm sorry, yes. So that would be a point. Plug in 1 into this, and we would get 2 out. Plug 2 in, so 2 squared is 4. 4 plus 1 is 5. Okay, we can plug some negatives in also. So negative 1 and negative 1 squared is 1, and 1 plus 1 is 2. And negative 2 squared is 4. 4 plus 1 is 5. So there's going to be some symmetry in this particular graph here, and it's going to do something like this. Now this particular curve here is called a parabola. This is known as a parabola. Now what's interesting about this is, I find real interesting, let's take this x squared over here to the left of the equal sign and leave the 1 over here to the right. Now I find this quite fascinating, is that no matter what point you pick, as long as it's on this parabola here, okay, and obviously there's infinitely many of them, if you plug the x in and the y in, it's going to equal 1. So no matter what point you pick here, so we'll say that's some point right there, we'll call it a b. Right, when you plug a in for x, and if you happen to know what b is, then b minus a squared is going to equal 1. So I don't care what point you pick, as long as it's on this curve, you know that if you plug both these ordered pairs in, it's going to equal 1. And I find that quite interesting. This particular point right here is called the y-intercept of the graph, and I think I'll just leave it at that. Okay.